Hello students, welcome to my YouTube channel Easy Mathematics. In our previous video, we just come to know what is D'Alembert's ratio test. There we say that when the limit n tends to infinity, un plus 1 divided by un is equals to 1, then the test fails. Test fails means at that point of view, the given series may be divergent or convergent. But why this ambiguity occurs, that we discuss with an example. We start with the P series. Everybody are familiar with the P series. So just look here, we consider the series summation 1 upon n to the power p. So here un is 1 by n to the power p, and obviously then un plus 1 is 1 upon n plus 1 to the power of p. Now if we take the limit to this ratio, then we find out that limit n tends to infinity n to the power p divided by n plus 1 to the power p, and for this we express in this form, and when we take the limit then the value is 1. So for all values of p, what we will find out, whatever be the value of p, we will find out this limiting value is 1. Whereas we know the P series is convergent when P is greater than 1 and divergent when P is less than equals to 1. That we know already. We have proved that the P series is convergent when P is greater than 1 and divergent when P is less than equals to 1. Hence, the given series is convergent and divergent both when this limiting value is 1. So, which is an absurd thing. Hence, for the limiting value, we cannot analyze a series properly, so that the test fails. So, I hope you understand that for the particular limiting value, we can't conclude a series uniquely. It may be divergent or convergent both depending upon some another parameter. That's why the D'Alembert's ratio test fails when the limiting value is 1. Now, a very important observation for D'Alembert's ratio test we should find out here. So, what is that observation? The observation is this test makes no reference to the magnitude of the ratio un plus 1 by un, but concerns only with the limit of this ratio. So, what I am trying to say, let us understand this one with an example also. So, if we just consider a very simple series, that is 1 plus 1 by 2 plus 1 by 3. So, here definitely un is 1 upon n and un plus 1 is 1 upon n plus 1. So, this ratio is 1 upon 1 plus 1 by n. If we take the limit, then the value is 1. So, the limiting value for this ratio we will find out 1. Now, actually what happens? The given ratio is what? N divided by n plus 1. So, as n is the positive value and n divided by n plus 1 is here, so always it should be less than 1 for whatever be the n value is. Hence, D'Alembert's ratio test fails as the limiting value is 1. So, to give any conclusion regarding the nature of the series, the D'Alembert's ratio for we can't get any idea. Rather, but just simply if we say this one is less than 1, so that we can say the series is divergent. So, this one actually the ratio gives us the just a ratio. It is not giving us the magnitude value. So, depending upon the only ratio, this ambiguity will occur, and that's so why we can't conclude properly. So that this one is a very big drawback of the D'Alembert's ratio test. Anyways, so let us do one more example supporting to this observation. Just look at this one. I hope this question is known to you, because this question I have given you while we do the comparison test. In the do by yourself question, you will find out the same question in the comparison test. I hope you solve. So anyways, here un is 1 plus 2 plus 3, in this way it is n plus 1 divided by n plus 1 its whole cube. If we simplify, then it becomes n plus 2 divided by 2 into n plus 1 its whole square. Now, if we will find out the n plus 1th term, then it should be n plus 3 divided by 2 into n plus 2 its whole square, just by replacing n by n plus 1. Now we take the ratio value. So un plus 1 by un is n plus 3 into n plus 1 its whole square divided by n plus 2 its whole cube. If we take the limit on both sides, then what we will find out? Then we will find out this limiting value is 1. Just observe, this one is the simplification and the value is 1. Hence, D'Alembert's ratio test fails. But actually, the given series is a divergent series. So by comparison test, we can consider the given series is divergent, and in comparison test, we consider the series for comparison as 1 by n, because the given series for the un term is this one, and here the difference of the power of n is exactly 1. That's why the Vn should be 1 upon n. On that basis, if we conclude from the comparison test, the given series is divergent. So D'Alembert's ratio test fails because it just gives the limiting value of this one. It will not concentrate on the magnitude of this value of this function. That's why we can't conclude from the D'Alembert's ratio test, but by using comparison test, we will conclude the nature of this series. Anyways, I am telling you again that not always comparison test is the most suitable choice. While D'Alembert's ratio test fails, that time we have some another test, Rabb's test, Gauss test, and the logarithmic test that we have to apply so that we will get the result very conveniently. And all those tests which I am telling you, like the Rabb's test, logarithmic test, Gauss test, all we are going to discuss gradually in our upcoming videos. So stay tuned. Till that, have a nice day and thank you all.